Do you have the skills to make compelling desktop applications with C# and .NET and want to bring those skills to mobile? If so, join me, Helen Miller. I'm a content author for Microsoft and a Xamarin developer, and I have several years' experience taking technical content and breaking it down to help desktop developers learn to go mobile. You will also hear from Mark Taparaskis, Jesse Dietrichson, Adrian Stevens, and Mark Smith, all experienced Xamarin instructors and expert Xamarin developers. Together, we will teach you to apply your skills to building compelling, interactive, and native cross-platform applications using C# and .NET in Visual Studio with Xamarin. Xamarin Forms lets you define a single UI that you can share across all of your supported platforms. This maximizes your ability to share code. You can share your UI and your business logic. In this course, you'll create a Xamarin Forms application and define your UI in code and XAML. You'll also see how to access platform-specific features, such as the phone dialer or camera, that do not have a shared programming model integrated into Xamarin Forms. We'll be guiding you through a series of videos and have provided exercises where you can apply what you've learned. We've also provided completed solutions so you can check your work. By the end of this course, you'll be able to create a new Xamarin Forms application, define your UI in code and XAML, and utilize styles and resources to minimize repeated code. We strive to create a 5-star experience for you. If at any point you feel this course is less than a 5-star rating, please let us know by leaving a rating and a review with what we should change or fix. We love hearing from you and will take your feedback into consideration when improving the course to better fit your needs.
And there's a lot of innovation happening in the mobile industry today. And typically when we hear the word mobile, we think phone. But we're rapidly seeing new device categories emerging, including wearables, IoT, and holographic. And users are now expecting their devices to always be connected, always be online, and generating and consuming data. Everything from checking the temperature of their home while they're on vacation to tracking their cabs, their flights in real time. And we're using more than one device to consume that data. Take a look at your desk right now. You're likely sitting in front of a desktop or a laptop, and many of you will also have a phone or a tablet close by. Now, this may not be unusual for developers, but now we're seeing casual users carrying 2, 3, even 4 devices with them, and they expect to be able to switch between them depending on what they're looking to accomplish. And it's not just for work. We're seeing smart devices in all aspects of our lives, and this includes, of course, entertainment, athletics, and healthcare. And these devices, or really more importantly, the applications running on them, need to work everywhere. That's across devices, across network types, and even across country borders. Okay, so we know users using devices, we know they want their data, but how are they consuming that data? Well, it turns out that users prefer applications. In 2014, we saw that users spent about 85% of their time on their devices using applications and only 15% using mobile browsers. And that trend is only increasing. In 2015, we see 90%. In 2016, we saw up to 92%. Users love apps. Great, so we need to reach our users, and we know our users want to use applications. So how do we go about making those applications? Well, we'll focus on the 3 big ecosystems. That's iOS, Windows, and Android. And writing an app means adding business logic and creating a UI. And using the traditional development approach, we would build our iOS application using Objective-C or Swift in Xcode, and we build our Windows app using C# in Visual Studio using the .NET libraries. And we would build our Android app using Java in Android Studio, use the Android Software Development Kit and the Java SDK. And writing applications for each platform means that we need expertise on each of those platforms with each vendor-specific language. So in these cases, that's C#, Java, and then either Objective-C or Swift. And the entire application needs to be repeated in each language. And take a look at the example code here. Even with this simple for loop, there are enough differences that you can't simply copy-paste the code between the platforms, and it can be tedious and even error-prone to write algorithms multiple times. And when using more complex types and patterns in the languages, that can mean even bigger differences, and this repetition of work continues when you need to make updates or fixes and requires significant care and attention to keep app features in sync. However, using the vendor-provided tools and languages means that we can write really powerful, performant, and compelling applications. We get the full access to all the platform features, and we get all of the benefits of using the platform-specific tools to write high-performance apps. And users prefer applications that use all of those features and use UI provided by the platform. They look and they feel natural. And what's expected of one platform can feel awkward or even wrong on another. So take tabs as an example. On iOS, we want those tabs to be on the bottom, but on Android, the tabs are at the top, and even more commonly, you'll see a flyout menu used instead. So what we really want is the ability to write our applications that can take full advantage of the power, the features, and the performance of each platform, but write the code in a common language. Or even better, share that code across these platforms to reduce our development time and to help keep our applications synchronized. And this is where Xamarin comes in. Xamarin is an app development platform that lets you build applications for iOS, macOS, Android, and Windows, and share code across these platforms. This includes desktop, Android phones, iPhones, Windows Mobile, but also includes other really exciting device types like wearables, IoT, Xbox, and even HoloLens. You can write your code in one language and deploy your application to all of the amazing devices that your users are using today. And of course, Xamarin is part of Microsoft, and that means that it seamlessly integrates with other Microsoft development products. So as a developer, you have access to end-to-end tooling to create, test, build, and distribute amazing applications. So let's explore Xamarin and see why we want to use it to create our mobile applications. Now with Xamarin, you're going to write your applications in C# using Visual Studio on either Windows or Mac OS. But it's more than just the C# language. You also gain access to the .NET libraries, and these provide features and standard APIs across all the supported platforms. And we have two development strategies with Xamarin. The first is to share your business logic and then write your UI uniquely for each platform. And this is a really powerful technique. You're able to use the exact same code for your business logic across all supported platforms and then take advantage of the unique UI features on each platform using native controls and the native design patterns. And this can allow you to share 70% or more of your code across Windows, iOS, and Android. And there's another option. There's also Xamarin Forms. Now, Xamarin Forms allows for even more code sharing in the form of a shared UI definition. With Xamarin Forms, you define your UI once, and then that UI definition is used to create the appropriate native controls on each platform. And we'll take a look at both approaches. So first, we'll start with Xamarin iOS and Xamarin Android. So these allow you to write iOS and Android applications in C#, leveraging all of the same features that are available to developers using Swift or Java. But you have the advantage of being able to share and reuse code between your iOS and Android applications. And this, of course, extends to Windows as well. And you can share this business logic with really actually any other C# platform. So it includes Windows UWP, includes WPF, or even ASP.NET. And you can also create your UI for each platform using the platform-specific APIs. But everything is written in C#. Now you might be wondering about API coverage. Now, can we use all of the features available to Swift developers? Can we use all those great new iOS 10 features? Well, yeah, the answer is yes, absolutely. Xamarin has 100% API coverage, but all accessible in C#. It's the exact same story on Android. 100% API coverage, and again, all available in C#. And can't forget about Windows. Windows is fantastic, of course. Microsoft already provides all of their development tools and APIs in C#. Now, when we talk about these platform-specific languages, let's look at Google, look at Android. So Google provides Android library types written in Java. And then of course Apple provides those library types written in Objective-C. Now, Xamarin provides a C# version of every one of these types. But Xamarin also exposes the platform APIs using common C# patterns. So as an example here, on Android using Java, you'd commonly see getter and setter methods. But in C#, we'd expect a property. And that's exactly what you'll use when you're writing Android applications with Xamarin. And Xamarin also offers excellent performance on each platform. For iOS, your application is fully compiled. It's a fully compiled binary, offering all the performance you'd expect of a native compiled binary on the platform. It's a native iOS application. On Android, Xamarin leverages the just-in-time compilation, so just like Java Android, and that creates an optimized executable on the executing device, on that Android device. Now, Xamarin offers native performance, and with the language advantages of C# and the runtime advantages, it can even sometimes create applications that are faster than apps written in those native languages. Now, next I want to introduce you to Xamarin Forms. So Xamarin Forms is going to give you the power to share not just your business logic, but your UI definition cross-platform as well. Now, it has over 40 UI elements that you can use to create your UI. And all of these will create the appropriate native control on each platform. And we'll see how this works in just a minute. And with Xamarin Forms, you can define your UI in XAML. And this is very much like the XAML you've been using as a Windows developer. And it also supports data binding, and this lets you achieve a really strong separation between your UI and your business logic. And Xamarin Forms includes a number of really useful APIs to help with things like navigation, animation, and even dependency injection. So let's talk about that shared UI definition. So in Xamarin Forms, the controls are really just abstract models, and for each Xamarin Forms control that you define in your UI, a platform-specific control is created. So what do I mean by that? Well, let's say we want to add a piece of UI that allows our user to enter text. In Xamarin Forms, we create what we call an entry control, which we can do in C#, but more likely we use XAML. And now when we run this app on iOS, the Xamarin Forms infrastructure will create a native iOS UI text field. On Android, the user would get an edit text, and on Windows, they'd be presented with a text box, all native controls for each platform. And this means that our shared Xamarin Forms UI definition is really a native UI. And it's a native UI on every platform using the appropriate native controls. You write your UI once, and you get the native look and feel on every platform that you support. And even though we're sharing our UI definition, the Xamarin Forms applications don't need to be boring. You can still make compelling, beautiful applications. And here's a great example. This is an app called Xamarin Sport, and it looks and it feels great on every platform by using strong color schemes, well-structured layouts, and tasteful use of the Xamarin Forms animation APIs. And that's something I want to share with you as well. This application is completely free and it's completely open source. When you're ready to dive into creating your Xamarin Forms applications, this is a great one to look at. And speaking of open source, did you know that Xamarin is also completely open source? Because all of Xamarin is open source, that means you can download the source code, you can review the code to see how things work, and even add features to extend the platform. And if you want to contribute, Xamarin does take pull requests. Now, we've covered a lot here, but we've really only just scratched the surface of what you can do when building applications using Xamarin. In this video, we'll discuss what's required to start developing with Xamarin. Now, first, you can use either a Mac or a Windows PC as your development machine, and depending on your development environment, you'll be able to target different mobile platforms. Mac allows you to target iOS, Android, and Mac OS, and Windows lets you target iOS, Android, and of course, Windows. Installing Xamarin on Windows can be done from the Visual Studio installer, either 2015 or, better yet, 2017, and you can even use the free Visual Studio 2017 Community Edition. Now, if you don't have Visual Studio installed yet, then the Xamarin tools can be installed directly from that first run of the Visual Studio installer. And if you already have Visual Studio installed, you can relaunch the installer and add it in afterwards. Of course, just make sure you've checked off mobile development with .NET. When using a Mac, the first thing you should do is install Xcode. And you'll need the latest Xcode from the App Store, and this means you'll likely need the latest version of macOS installed as well. And then you can download the Xamarin Unified Installer from Xamarin.com or install Visual Studio for Mac, and then go through the installation process. This is going to install Visual Studio for Mac as well as the Android SDK tools. And once it's finished, you'll be ready to start building Android, iOS, and macOS applications. Now, once everything is installed, you'll want to check for updates. On Windows, the Xamarin updates can show up via extension updates or full Visual Studio updates. And on the Mac, you can use the Visual Studio application menu and then select Check for Updates just to find any pending updates. Now, when you do the update on macOS, you'll see a dialog similar to this one, and it says two things of interest. So first, it shows you if any updates are available, of course. But second, it lets you change the release channel, and Xamarin has 3 of these. We have Alpha, and this is where you'll find the latest version of the software. And this is often a little bit fragile, right? It's Alpha version and subject to change as it evolves. There's Beta, and this has the APIs locked down, but it still might have some issues, but the shape is not likely to change. And then of course there's Stable, and this is the released tested version. And we generally recommend you use the stable version unless you want to test out some new features or upcoming APIs. Now, Visual Studio on Windows bundles early access features into Visual Studio Preview, and there's a download available to everyone. You can go to visualstudio.com/vs/preview. And the preview can actually be installed side by side with the stable version of Visual Studio, and this allows you to test out the latest things without breaking your dev environment. Now, we can do our development on Windows with Visual Studio even when creating iOS applications. However, Apple licensing requires that we build the app on a Mac. And this means that we can't do everything on the Windows side, and you'll need a Mac to actually do the final compilation. Now, Xamarin helps out with this, and they do this by installing a service on a network-connected Mac known as the Xamarin Mac Agent. Visual Studio can connect to this process and then delegate a portion of the build to this Mac, allowing us to compile with the native toolchain and even launch the Apple-provided iOS simulators. And this just means you'll have to have the Xamarin tools installed on this network-connected Mac. So here are the basics of how it works. When you create or open an iOS project with Visual Studio on Windows, the IDE attempts to connect to a Xamarin Mac agent. If you've already established a connection, it'll remember that connection and try and reconnect. And if it's unable or you haven't already set up a connection, then you'll be prompted to, connect to a build host. Visual Studio connects and interacts with your Mac using a secure SSH login. And this is actually important because remote login is typically disabled by default on most Macs, and so you'll need to do just a little setup before you can connect. Now, the connection wizard will walk you through the necessary steps to turn on remote login, and it's not too difficult. You're going to log into your Mac that you want to use and access the sharing preferences, as you can see here. Then select the checkbox next to remote login, and then make sure that your user ID is listed among the allowed users to remotely access this Mac. Once you've got your development environment set up and can build your app, you're ready to run and test it. And there are 2 options. You can install your application onto physical devices that you have in front of you, or you can run the software on simulated devices on your computer through the use of emulators and simulators. Apple provides an iOS simulator with Xcode, and the Xamarin tools create native iOS apps so we can use the same testing tools. The simulator can be launched with your application from either Visual Studio for Mac or Visual Studio on Windows using the build host. Now, by default, the simulator always runs on the Mac, so if you use Windows to build your app, the simulator will actually launch on the Mac. This means you'll need access to that display and even the mouse and keyboard of the build host machine, either physically or even through some kind of remote desktop. And the simulator supports a variety of devices and resolutions as well as different versions of iOS, so it's a really fantastic way of testing. Now, Xamarin also provides a remoted iOS simulator for Windows developers, and this lets you view and interact with your iOS application right from Windows. Now, your application still runs on your Mac, but it's visualized on Windows. Now, the remoted iOS simulator is a separate download, and it requires Visual Studio Enterprise. Now, Now on the Android side, you've got a few choices, and the simplest option is to use the emulators installed with the Android SDK. Google supplies a set of emulator images called Android Virtual Devices, or sometimes AVDs. And they can require a couple of steps to get things optimized, but once you've got them up and running, they're quite fast and support a wide variety of device types and OS versions. Now, the best Android emulator experience is to install and configure the Google emulators using Android Studio, and that's Google's development IDE. This is not installed by Xamarin, but it is a free and separate download. So once you install Android Studio, you can create a new AVD image from the AVD editor, and this can be launched through a toolbar button on the Tools Android menu. Now you may need to create a dummy project just to get into the full menu, so just create any Android app and then delete it when you're done configuring your emulators. And finally, we have Windows. And on Windows, we have the Universal Windows Platform emulators, which ship with Visual Studio. Now, these UWP emulators have two types. There's Windows Mobile, which is Windows 10 on a phone form factor, and the UWP Desktop emulator. You might be thinking, why would I need a desktop emulator? I'm working on a desktop class PC for development. It's actually really useful. It's great for testing your application on different screen sizes, different screen densities, and to test things like rotation and gestures. This is an optional install, so make sure you select it with the Visual Studio installer. And the emulators do require Windows 10 with Hyper-V enabled. And Hyper-V is an optional install. If you have it installed, Visual Studio should turn it on when you install the UWP emulator, but if not, you can use the control panel to add it yourself. You should now be ready to start developing with Xamarin. Now, if you have any difficulty setting up your Xamarin development environment, we strongly encourage you to take the free live Xam 101 class at university.xamarin.com. There, you'll be able to get assistance from an expert Xamarin University instructor who will be more than happy to help and answer any questions you may have.
In traditional Xamarin development, we share our business logic in the form of a portable class library or a shared project, or perhaps a combination of the two. We then add references to these libraries with our common code to each of our supported platform-specific projects. That allows us to share all the things defined in these libraries with our Android, Windows Phone, and iOS projects. The code we share in this approach typically includes things such as view models, business logic, web service access code, and data structures, things we can cleanly define in C# using .NET APIs that are common to all three platforms. And this is often about 75% to 90% of our code base, depending on how complicated the application is. That still leaves anywhere from 10 to 25% of our code base that ends up being platform-specific and defined in a platform-specific project that targets iOS, Android, and Windows Phone. And this is where you take advantage of something that is platform-specific. Maybe you'd like to use the NFC APIs in Android, or the Touch ID API in iOS, for example. This platform-specific block also includes the definition of the UI. This is typically the UI defined using native platform controls and any UI-specific features that you want to take advantage of, such as maps or perhaps specific gestures. This traditional Xamarin development approach works great, and it lets you share the majority of your code, and most Xamarin applications today are built using this exact approach because it's mature, it's flexible, and it's been around since the beginning. However, one of the common questions heard at conferences and from our developer community was, how can I craft the UI in the shared code? And that's where Xamarin Forms comes in. Xamarin Forms provides a library of common controls which are implemented across all three platforms, and it allows you to define the UI in your shared code. And at runtime, these shared controls create native views for each platform. So you still get the native look and feel, but you only have to write the UI once and have it shared on iOS, Android, and Windows Phone. So looking back on our layers, we'll still have some platform-specific code. There are likely features that we'll want to leverage which are not cross-platform, but the UI definition will not be part of this unique code base. Instead, that's going to be shared just like the business logic and the data layer. Now, it's important to understand that Xamarin Forms is just a UI layer. It doesn't change how your app is deployed or how it gets executed at runtime. You're still going to have separate native applications for each platform that you want to support, just like the traditional approach. So, what are our runtime requirements for Xamarin Forms going to be? Well, on Android, you're going to need to install the latest Android SDK to compile against. And you'll need to keep this up to date. As Xamarin Forms gets versioned, it requires that we update to the latest Android SDK. You can then run the created application on any device with Ice Cream Sandwich or higher. On iOS, Xamarin Forms requires a runtime target of iOS 6.0 or later. It supports all variations of the devices, so you can run your apps on iPods, iPhones, and iPads. And just like the traditional Xamarin approach, it's going to require a Mac to build and deploy the application package. For Windows Phone, you can build an app which targets any version of Windows Phone 8.0 or later. Keep in mind that all of these are separate projects, so the UWP app will be a separate binary from the Windows Phone 8 version. Xamarin Forms supports the tablet and desktop style as well, so you can run your app on Windows 10 or on a Surface Pro in tablet mode. Xamarin Forms provides support to build fully interactive user interfaces by including support for a standard set of controls, things that you're used to, such as buttons, edit fields, labels, pickers, sliders, and even scrolling lists. It also has a flexible layout system, which lets you position elements on the screen in an adaptive fashion so your UI resizes based on the device that it's running on. Where the platform supports it, Xamarin Forms includes support for basic maps. It also has several navigation patterns, including master detail, stack navigation, tab navigation, and page style navigation. If you're coming from the Microsoft platform, you'll be happy to know that Xamarin Forms supports the use of XAML to define your UI in a markup format. And as part of that XAML system, there's a full data binding infrastructure, which allows for separation patterns, such as MVVM, to be used to connect your data to the UI. Finally, Xamarin Forms supports styles and triggers, just like the Microsoft XAML platform, to standardize the look and feel of the app and provide runtime changes based on events or bindings. So then the question becomes, should I use Xamarin Forms or the traditional Xamarin approach? It might be an odd question to ask given that you're going through a class on Xamarin Forms, but you should be aware that Xamarin Forms isn't always the best approach to use for some apps. In some cases, you'll find that using the traditional approach will actually be easier depending on the type of application you're trying to build. Both approaches have their benefits and drawbacks, but there are some common questions you can ask yourself to help guide your decision. First, is the application you're trying to build oriented around data entry? Another way to say this is the application mostly composed of data forms? This sort of enterprise-type application is well suited to Xamarin Forms and is in fact the exact scenario that Forms was designed to solve, and so you should use Xamarin Forms for that. Another common case is when you're trying to quickly prototype an app to work out the logic or show off to investors, and this is another perfect case for Xamarin Forms. You can try out concepts quickly and without spending a lot of time designing the UI. Speaking of the UI, one important question to ask yourself is, how important is pixel-perfect design to your application? If it's not important and you're okay with subtle changes in the design between platforms, then Xamarin Forms might be suitable for this app. Many things such as spacing between elements and some of the colors of the controls are actually left up to the platform and they're not easily changed in Xamarin Forms. So if you're trying to reproduce a pixel-perfect design, then Xamarin Forms is not a good fit because it's almost impossible to completely control that in every situation. Finally, if your app will utilize specific controls unique to the platform or have a significant investment in platform-specific APIs, then Xamarin Forms is probably not a good fit for this app, and you'd be better off using the traditional Xamarin approach where just the business logic is shared. I'm going to use the new project here on the start page, and I'm going to go to Installed Templates, Visual C#, Cross-Platform, and then I'm going to pick either blank app Xamarin Forms Portable or blank app Xamarin Forms Shared. Again, this is similar to what we had in the wizard in Xamarin Studio where we could select between the portable class library or the shared project. And that's exactly what we're able to do here. I'm going to give this the same name, First App, and I'm going to put it on my desktop and click OK. That's then going to go ahead and generate the project for me. Now, in this particular case, it's going to take a little bit longer because it's got to generate an additional project. Since I'm on Visual Studio on Windows, I'm going to get my portable class library project, First App. I'm going to get an iOS version, I'm going to get an Android version, and I'm going to get a Windows Phone version. And so here you can see my project's been created. We got a little getting started page. I'm just going to close that along with the app.cs that it opened automatically. And I just want to look at the solution structure here. It's going to look identical to what we had in Xamarin Studio, with the exception that now I have a First App.Windows Phone version This is for Windows Phone 8.0 Silverlight. That's what the template currently creates. That will likely change over time as we migrate more to the Universal Windows platform. However, notice that we have the same issue that we had before in the sense that our references here use Xamarin Forms. And if we go look at the packages, we don't actually see it here, but if we go look at the packages, notice that it's a fairly old version, 1.3 here. And so just like in Xamarin Studio, I'm going to want to right click on my solution here, and I'm going to go to this Manage NuGet Packages for Solution. And it will allow me to restore all of my packages, but even better, I can see that there are updates available. So if I click the Updates tab, you can see I have updates for Xamarin Android Support v4. Now we know we're not going to be able to update to that, but I can select this one and update to v2006490. That'll go through and update all my NuGet packages for all the projects in my solution. Again, it's one of the first things that I'm likely going to want to do just to make sure I'm on the most current version of Xamarin Forms. Now you can see that we actually have a bunch of other updates that we could apply here. Again, these are all coming from the support libraries, 23.1.1. We know that that's not compatible with the current version of Forms, and so we don't really want to update those. But you can try. It will give you an error in this particular case, but future versions of Forms likely will support this. Now notice that I did get an error out of Visual Studio as well. The package failed to uninstall. Restart Visual Studio to finish this process. All that means is that there's a folder that's left in the directory structure that needs to be deleted. And so you can hit this restart button to go ahead and restart now and remove that folder, or you can do it at a later time. I'm just going to go ahead and close this. And now we're ready to start actually adding in logic into our app. So now it's your turn to try this.
There are two types you will work with in the cross-platform code to build your Xamarin Forms application: the application class and pages. The application class is a cross-platform entry point to your application. It is located and used by the platform-specific code to initialize the application, and the project template will always create a derived class from the application type. It will point to the first page of the application. The page is used to display a single screen to the user. It defines the UI, either in code or markup, and provides the behavior for the screen. The application class will always identify the starting page through a property, and then you can create the other pages to navigate to through various built-in mechanisms. As you saw, our custom code typically starts in the application class. There is only one of these. The system enforces this through the singleton pattern. The default project template creates a custom class that derives from the Xamarin Forms application class, and you get to it from anywhere in your application through the application current static property. There are several interesting things available on the application singleton, including virtual methods related to lifecycle notifications, the main page property, which references the currently displayed screen. If you change this property, the screen changes. Events which are raised as navigation happens in the application, and basic support for managing application state persistence. One thing to note here is that Windows Phone projects all have an application class as well. Android also has an application type, but it's not used in the default project templates from Xamarin. Make sure you don't confuse these same name types as you work with your Xamarin Forms application. The lifecycle methods are virtual methods your derived app class can override. The default template actually creates the overrides for you. You can just add code in. There are 3 methods. Use the onStart override to initialize your application's data. This method is called when the app is launched and it was not running. Here you can load data from persistent storage, hit web services to cache off data, and to perform other launch type activities. The second method is onSleep. This is called when the application was active and the user switches away to another application. We sometimes refer to this as backgrounding. Often, you don't really need to do much with this method. The data is still on your screens and all of your data is still available. The one thing you might need to do here is refresh your screen with current data. For example, consider a weather application. If it is suspended and then resumed, the data on the screen could be hours or even days old. Applications that display external volatile data which changes over time should use this notification to refresh their data. Application UI is defined in terms of pages and views. Recall that the app.cs file is the starting point for your application, and it will identify the main page for that application. Pages are used to describe a single screen for your application. Then we add in views, which represent the individual controls or widgets that the user will interact with. Page represents a single screen in your application, and your application will always have at least one of these. This is an abstract class, and there are several derived types that are used for a variety of purposes. One of the main page types you will use is the content page class, which is used to hold a single piece of content assigned through a property named content. Most apps will subclass content page for each screen they create, and this is actually the default page added into your app. Next, we have master detail page. This has two properties, master and detail, which are assigned to pages, typically content page objects. This page then manages displaying the other two pages together, sliding the details out based on the isPresented property. True equals master page is visible, false equals detail page is visible. On a tablet device with more screen real estate, the system will allow both master and detail pages to be displayed at the same time. Navigation page enables typical stack-based navigation with a navigation bar header where you push child pages onto the stack and they become the active page. Popping them off then restores the previous page. The constructor for this page type takes the initial child page to display, and just adding this into your app causes your application to get a native navigation bar. Tabbed page allows you to switch between a set of child pages, again typically content page objects, through a tab bar running on the top or bottom of the UI based on the platform. The child pages are all added to the children collection and can have a title and an icon associated with them. There is also support for overflow if too many tabs are added and the device does not have the capability to display them all at once. The carousel page enables swiping left or right to change from one page to the next, similar to the pages in an ebook. Like the tab page, the pages are set into a children collection and this page class navigates between them. Next, you will populate your pages with views. These are typical controls you have used in other UI frameworks, and all of the common ones you'd expect for a mobile platform are present here. The Xamarin Forms controls you use to describe the UI are really just a model definition. At runtime, each platform, iOS, Android, and Windows Phone, will take the object graph you create and turn it into a native representation using native platform-specific controls. The piece of code that does this is called the renderer. Each control you use in Xamarin Forms, including custom ones you might build yourself, must have a platform renderer registered for it, which will create the appropriate visualization based on the properties set on the control. For example, if we create a Xamarin Forms button and set the text property to Click Me, then on Android, the Android platform renderer will take that definition and create an Android widget button in response. On iOS, the iOS platform renderer will take that definition and turn it into a UI button. And on Windows Phone, the WP8 renderer will create a system Windows button. The important thing here is that you define the UI in a shared fashion once, but you get a native UI on each platform that looks and feels natural to that platform. You might have noticed that the content page only allowed for a single piece of content to be displayed. It must be a view, such as one of the controls we looked at in a previous video. If you want to display multiple views on a page, you must use a layout container. In Xamarin Forms, much like in Android and WPF and Silverlight, we manage layout with different layout containers, selecting the container based on how we want the content to be organized visually. You add child views into the layout containers, and it will then organize that content based on the type of container you use. Rather than specifying positions with coordinates, you use layout containers to control how views are positioned relative to each other. This provides for a more adaptive layout, which is not as sensitive to dimensions and resolutions. Xamarin Forms ships with several layout containers, each of which enforces a specific style on all child views you add to them. Let's take a look at those containers now. Stack layout is one of the most common layout containers you will use. It organizes content in one of two ways: top to bottom or vertically, and left to right or horizontally. You can control this through the orientation property. The orientation of a stack layout is set to be vertical by default. When you set the property to horizontal, it will stack the views left to right. Absolute layout provides pixel positioning where you define the exact placement of each child. This is similar to the Android container with the same name and the Canvas panel in WPF and Silverlight. This is also the container closest to how you would program in iOS. This container actually has a feature that XAML does not. It supports proportional positions and sizes. Relative layout allows you to define the position and size for each child using relationships based on the container. The position and size are calculated at runtime using delegates that the code must supply in the form of constraints. These constraints can be fixed values, dynamically calculated values, relative to the container, or relative to the sibling. A grid container organizes its children in a table format, similar to the HTML table, except this is strictly for layout purposes. WPF and Android also have this container style. Scroll view provides a scrollable container. If the single piece of content added to the scroll view is larger than the viewable surface, then the scroll view provides touch-based scrolling in the horizontal or vertical directions, or both. To add or remove views to a layout container, you insert and remove them from the Children collection. This is a property exposed by each layout container, and you can add or remove views at runtime to dynamically change how the UI appears. The order the views appear in the collection determines the order they are drawn and appear on the screen. This is particularly important with containers that allow for overlapping views such as grid, relative layout, and absolute layout, as it determines which view is on top. The child elements can request specific sizing and spacing when hosted in a managed layout container. These are actual properties defined on the control, the layout container, or the page itself. Vertical options and horizontal options determine how child content is stretched or positioned. It can be used on any view type, but most often is set on layout containers. Spacing is used with a stack layout container. It adds spacing between child elements and is rendered in the platform measurement system. Padding can be added to any page type. It adds padding around each element. In a similar fashion, controls can request a specific width or height or a minimum width or height using properties on the view base class. Width request and height request request a specific width and height for the element. These will override the measured size of the element. Minimum width request and minimum height request request a minimum width and height. Views can be made larger to fit the content if necessary. Most of the layout containers respect these properties, and in fact, for unmanaged containers, you must supply a width or height request, or the control may not be rendered. You cannot set width or height properties directly. They will just report the actual or final width and height. Bounds is similar to the iOS frame property. It reports the position of an element relative to the parent. In Xamarin Forms, remember that each of our applications is made up from two components: shared code, or the portable class library, which holds our logic and UI definition, and the platform-specific projects, which are the actual applications we will deploy to the devices and app stores. The PCL is great because it's shared, but it has significant limitations in terms of the APIs we can use. Many platform features which make iOS, Android, and Windows Phone unique are unavailable to us. First, there is a built-in API in Xamarin Forms for fine-tuning the UI on a per-platform basis. It has two variations. Device.onPlatform takes 4 delegate methods, one for each platform, and one for the default case, if you don't supply a platform-specific delegate. Each parameter defaults to null. This style allows you to execute a block of code uniquely based on the platform the app is running on. So if we were on iOS, then only the iOS delegate would be executed. Or if it is null, then the default delegate is executed. No result is returned from this method. The second variation is a generic device.onPlatformT, which takes 3 T parameters and returns a T. The 3 parameters correspond to iOS, Android, and Windows Phone. There is no default parameter case here. You must supply all 3 values. This method is useful if you want to change a parameter or property based on the platform you happen to be running on. For example, we are adjusting the top of the thickness class based on the iOS platform, returning only 20 for that case. Again, the important thing here is we are putting this into our shared code, but making it execute a specific branch or return a specific value based on the platform we are executing on at runtime. Xamarin Forms exposes a few other features that most applications need. The static device class has several other useful methods for invoking platform-specific functionality. You saw device.onPlatform just a moment ago, which lets you invoke different logic on each platform. It also has a device.os and a device.idiom property to identify the platform and footprint. You could use these in conditional branches. The important thing to remember here is that you use this sort of logic in your shared code. It does not allow for any additional platform-specific APIs here. It simply lets you execute logic based on the platform and form factor of the device. Xamarin Forms has support for dealing with a few very common platform-specific features. There is a device.openURI to open a URI using the platform handler. For example, if you pass in an HTTP URL, each platform will open that browser app and launch that page. The page.displayAlert instance method can be used to show a 2-button modal message box. There is also a page.displayActionSheet that supports more buttons. Device.startTimer can be used to create a timer. Return false from the delegate to stop the timer. You can use device.beginInvoke on main thread to marshal the UI thread if you are on a background thread. This will use the appropriate platform-specific method. Alternatively, you can also use a .NET synchronization context. This is particularly useful for classes you are sharing with non-Xamarin Forms platforms such as ASP.NET or a desktop app. Finally, there is also support for cross-platform mapping with the Xamarin Forms.Maps component, which is an optional install. This abstracts out the mapping support from Google, Apple, and Microsoft into a component that is cross-platform. Xamarin Forms has some really useful APIs, but it doesn't expose everything from the platform. In fact, it is very likely there will be some feature you need to use which is not available to your shared code. For these cases, we have to put a little architecture thought into our application. We will want to use the APIs available in the platform-specific project, but somehow invoke them from our shared code. For example, consider dialing the phone. All 3 platforms have support for this feature, but each one accomplishes it slightly differently, and to fully control it, we would want to write that code uniquely per platform. Let's take a look at what Xamarin Forms has to offer for situations such as this. First, you'll want to create some form of abstraction. That might be an interface or a base class, but something to represent the feature you want to use in your shared code. Best practice dictates that we build an abstraction implemented by the target platform which defines the platform-specific functionality. Here you can see that we will define an iDialer interface which will describe how our code will dial the phone on each platform. Then, in each of the platform-specific projects, we will implement that interface using the platform-specific APIs available to us in those projects. Our shared code will always use the interface, which means it is not directly tied to the implementation or platform-specific code. Platform projects implement the shared dialer interface using the platform-specific APIs to locate the implementation. We can use a variety of techniques to do this. Often, it is either a variation of the service locator design pattern or the dependency injection design pattern. It really doesn't matter how you bind to the implementation. The key thing is the separation being used here. Xamarin Forms includes a service locator called Dependency Service, which can be used to register platform-specific implementations and then locate them through the abstraction in your shared code. When creating your own abstractions, you can roll your own locator object or provide a singleton property that your platform-specific code assigns. Alternatively, Xamarin Forms has two built-in mechanisms. The first is a generalized messaging service called Messaging Center that acts as a publish or subscribe event system. You can send the message from anywhere in your code and have some handler to receive the message and then process it in a platform-specific way. This is exactly what Page does when creating alerts and action sheets. The second way is to use the Dependency Service API. This is specifically designed to locate and bind interfaces or abstract classes to implementations. The first step is to define our abstraction, the iDialer interface in this case. Again, this must be in our shared code since all parties need to know about this class or interface. Next, we will implement the abstraction in each of our platform-specific projects. Here, we define it for iOS, but we would also want an implementation in the Android and Windows Phone projects. Notice that it does not need to be public. External users won't know about the class directly. They will only reference it by the abstraction. Next, in each of the platform-specific projects, we let the dependency service know about our implementation using the dependency attribute. This is declared at the assembly level, as you can see here, and identifies the implementation, which is then registered with the dependency service. In Xamarin Forms 1.3, you can also use a new register method to add specific instances or types to the dependency service in code versus declaratively with an attribute. This allows you to make runtime decisions about the implementation of the service or to instantiate a service implementation with a parameterized constructor. Finally, anywhere in your app, you can request the abstraction from the dependency service. It will return the first registered class that implements the specific interface or derives from the specified base class. If no class is found, null is returned. This means you can implement a service for one platform, but leave it off for another if it's not possible to implement it or it's optional.
Suppose you had an app like this to translate and dial a phone number. The UI is really simple. You have at the top a label to prompt the user. Below that you have a text entry field where the user would type in the phone number, and then you have two buttons. When the user clicks on the button, you translate the phone number and update the text on the call button. When they click the call button, you pop up a confirmation dialog, and if they click yes, then you go ahead and dial the number. You could implement the entire phone word application in code. So here we are in the C# file. We might start off with some fields to store the controls that we're going to need to access from code. And then in our constructor, we would create the controls and set some properties. So for example, create the label, set a couple of properties on it, create the text entry field, pre-populate it with a sample phone number, create the translate button, create the call button, and notice that one's going to start off as disabled, and it's not going to become enabled until we have a phone number to call. Then we create a container to arrange the controls. In this case, we're going to use stack layout. Add all the controls to the stack layout. Set the content of this page to be the stack layout panel, and then just add a little padding around the edges. So all that code right there is the user interface part. Then we would also have the behavior here in code. So for example, we could subscribe to the click event on the two buttons. There's the stub out of the method. In translate, we're going to translate the phone number and then update the text on the call button. And in the on-call method, we're going to do a little bit of confirmation with the user, and then if they say yes, we're going to go ahead and dial the number. Here's the code for the app we were just building all in one place. And if we look at the code here, we'll see that there's two categories of stuff. There's the code to build the user interface, and then there's the code to implement the behavior. And of course, it's all together in a single file. This kind of approach, where you build the UI dynamically, does have one nice advantage. The UI itself can be different depending on the data that you're trying to present. So notice it's not that the data changes between runs in this case, it's that the UI itself can adapt to different data sets. Because you're producing it in code, you can present different controls based on the data that you receive from a server or something. So that situation is one really nice benefit of building the UI in code. However, that doesn't come up very often. And on the other hand, building the UI in code is actually quite limiting. It means that you have to have a developer that's building the user interface. There's no possibility in this case to delegate that work to a dedicated UI designer. So that's a bit of the motivation for a different approach. We're going to use something called the Extensible Application Markup Language, or XAML, to define our user interface. So it's a markup language that's intended and dedicated towards building user interfaces. Instead of the traditional approach where you write code, you use markup instead. So here's that same example again, slimmed down just to the core elements. If we code this in XAML, we end up with something like this. Instead of allocating objects using new, we have element tags in our markup. Instead of adding the controls explicitly to the stack panel, we just nest them inside the panel in the XAML. And similarly, instead of assigning to the content property of the page, we just nest the stack layout inside the content property of the page. Many people think that the XAML approach is more readable. For example, in the XAML, you nest the controls inside the layout panel. And just at a glance, it's obvious that those are the children of the stack layout. And it's much more obvious than it is in code. So if we fill this out a bit, we end up with XAML that looks something like that for the user interface. So this is the XAML that's equivalent to the code that we wrote earlier. This is the entire declaration of the user interface in a single dedicated source file. So it's completely separated from the behavior. If we look at the code now, all the user interface stuff is gone. Instead, what we have here is just the behavior, no UI. So to summarize, XAML gives us three really nice benefits over doing the UI in code. The first is this division of labor. We split up the work between a UI designer and a developer. Second is, XAML tends to be very tool-friendly. So it's possible to use a design tool to do a lot of the UI work for you. You've probably seen tools that work like this, where you have a design surface and a toolbox full of controls where you can drag controls from the toolbox onto your design surface. And there's a nice properties editor where you can set properties all in a nice graphical user interface without ever directly editing any of the underlying markup. And finally, we get a really clean separation of our UI from our behavior.
When Microsoft started designing XAML as part of .NET 3, they did it specifically for WPF, and they pulled from a variety of internal teams across the organization for advice. And in particular, they looked at the DHTML group, which was defining the HTML specifications for Internet Explorer. The time frame is important because a lot of people ask why Microsoft built XAML at all, and why not just use HTML and CSS. It becomes clear when you realize that XAML and WPF were being designed long before HTML had solid standards behind it. CSS didn't really exist yet, and most browsers interpreted HTML slightly differently, and as a result, it just wasn't mature enough. It didn't really offer the power or flexibility that we see today in browser-based applications. It was then used with Silverlight, which was a bright star that burned out quickly. And when Microsoft moved to the WinRT platform, XAML was implemented as a core UI platform for both .NET and C++ applications. That platform has now morphed into the Universal Windows platform, where we can share that UI definition with both Windows desktop and phone apps. As you can see, XAML is used by every major application platform defined by Microsoft today. It's very mature, it's highly extensible, and it's easy to understand because it doesn't introduce its own tags, but instead uses the underlying object model for any UI screens that are being designed. As such, it's a great way to describe your Xamarin Forms screens as well. If you've done any Microsoft UI development in the last few years, then it's likely that you've done some XAML already. The XAML used by Xamarin Forms follows the XAML 2009 specs that were published by Microsoft, and it includes almost all the features described in that document, including things that aren't supported in Microsoft's implementation yet. So the structure of XAML and how it works will be very familiar to the Microsoft XAML crowd, but the controls and elements that you use to build up your screens will be a little different. As an example, here we have a sample page defined for a WinRT application, which displays a text box, a password, and a button organized vertically. The root container is a page, and we use controls and layout containers that are very specific to the WinRT world. This same structure could be created for WPF, but some of the controls and properties would be different. For example, in WPF, the root element is most often a window. That same page in Xamarin Forms would look something like this. We use the same control for text entry in both cases. One is marked as taking a password, and the button here has a text property, not a content property. The root element for most of our Xamarin Forms pages will be a content page. But you can see the similarity and how the XAML definitions themselves are exactly the same. The key difference here is in the controls that are being used. That means that most of your Microsoft knowledge will transfer straight over. You will need to learn some new classes to work with, but the syntax and the features available to you are fairly compatible. As an example, here are some features commonly used in XAML-based apps. We often use shapes to add in new UI elements. In Xamarin Forms, we only support the box view class, which is a subset of the rectangle shape, but you could create your own custom classes to be able to fill the gap. We have support for resources, styles, and triggers, so you can store common things such as colors and fonts in your resources and then share them and use them across different pages in your application. In the same way, we can create custom styles, both implicit and explicit styles that get applied to all of your controls to ensure that things look uniform as you move from page to page. We have a full data binding infrastructure that supports data templates. Most of the features that you're familiar with from the WinRT world are available here. There are some differences, however. For example, update source trigger and relative source bindings are not currently supported. We support custom controls, both in the form of being able to define your own Xamarin Forms controls that then translate to some platform-specific control, but also being able to customize what a control actually looks like. And there are several variations to this. You can actually replace the renderer for a control. That's what defines what native platform control is going to be used to represent it in the UI, but you can also apply special effects. These effects classes allow you to then just tweak the control's representation on the platform. For example, you may want to supply a different style border around a button on a certain platform. You could use an effect to do that. Or you may want to turn on a certain feature on a certain platform that you know exists for a given platform control. You could do that with an effect as well. We also do support control templates, but they're slightly different in the Xamarin Forms world if you're familiar with them from the Microsoft world. In the Microsoft world, the control template actually defines what the visual representation is going to be. In the Xamarin Forms world, the control template is really just a template for a content page. And so we can put placeholders into the page and then fill them in with specific data. It allows you, for example, to create a login page, but then customize that login page on an app-by-app basis by supplying different elements for the control template itself. We also have support for animations. However, the animation support is strictly code-driven, so you can't actually interact with it from XAML. You have to do that in code. And then finally, we have behaviors. And so for those of you that have used Microsoft XAML, or in particular, Blend, the design tool, you're familiar with the behaviors toolkit where you can drag behaviors onto controls. We don't currently support any sort of design tool. However, we do have a behaviors framework. And so if you've used behaviors in the past to be able to add new features into controls or inject behavior into a control, then you'll find that similar platform is available here.
An interesting thing happens with properties. You might have noticed that we use strings to set the property values. This is the only valid thing we can use for an XML attribute value. However, in most cases, the actual property value is not a string at all. Here we will look at 5 different properties being set, each with a different type. Text is a string. No conversion is necessary. Rotation is a double, which can be converted from a string. Vertical options is an enumeration type and is matched to the name. Font is a complex object that uses a type converter. Color is a simple object which also uses a type converter. Type converters have been in .NET since 1.0 and are used to take strings and turn them into some object type. You can write your own type converters and associate them to your own types to make them XAML friendly, but the system provides many of the common ones you might need. Most of the built-in classes in Xamarin Forms have associated type converters so they can be easily created in XAML. For example, as you can see here in the label, you can customize the font by setting the font attribute property to values such as bold and italic, or a combination by separating them with a comma. The system will assume this to be a flags-based enumeration and apply the bitwise OR of the values. The font size property can be specified as a numeric value which is translated to a platform size, such as density pixels on Android. Or you can use a name size such as small, medium, or large, which is mapped to the platform using device-specific sizes. The color type converter supports creating colors from the named color set available in code behind, or using the HTML hex syntax. The thickness converter supports the creation of a thickness object using a single number, 2 numbers, or 4 values for each edge. These variations match the constructors you use in code behind. Type converters are great for simple property settings. But in some cases, we really need to create a full object with its own property values to assign to the property. Remember that in XAML, to create an object, we use an element tag. The solution to this problem is to change the property assignment to use an element-based syntax. This is called the property element form, and it involves breaking the property setter out into the parent-child form where the property name is expressed in an element tag with the name type.propertyName, as shown here with the box view.gesture recognizer. The child tag is then expressed as an element tag, which creates the object and assigns it to the property. Anytime you need to create a new object, set properties, and then assign that object to the property of another object. Another interesting property type is the attached property. Recall, these are special properties which are not actually defined on the type at all, but are instead defined by some other object, typically a parent, and then added as runtime values to each child. We use these for layout purposes to indicate where each child should be placed. Here you can see how we set attached properties in XAML. It looks like a normal property, except we have the owning type prefixing the name of the property. Anytime you see a type prefixing the property name like this, you know it is an attached property. With many types in Xamarin Forms, you have a single property that is used to supply content. On a label or a button, this is the text property. On a layout container, this is the children property. And on the content page, this is the content property. These properties are almost always set, and so XAML allows for an interesting shortcut in their assignment. You can, of course, set them like any other property using the syntax we've used up to this point. However, you can also set this property by simply putting the value between the open and close tag of the object itself. For example, compare the top and bottom values. We can fully break out the content page.content property or omit the property element and just set the label as a child tag. These will set up exactly the same object graph. This is referred to as the content property, and it's established by a little metadata added to the type through a custom attribute on the class definition. It's a nice convenience, particularly for the layout container, so we don't have to use the property element syntax to set the children. Xamarin Forms associates almost all the built-in namespaces with the default namespace declared at the top of the XAML file. That's why you don't need to specify the namespace for a button as part of the tag. This definition will change for each technology you work with. There is a second namespace defined named X. This will be the same definition no matter what technology you are working with, and it defines all of the available XAML keywords. This is also where you will find intrinsic CLR types like strings, integers, and doubles. These two namespaces will be present in every XAML file you create. XAML can actually create almost any object type, not just Xamarin Forms types. To create a custom type, you need to supply the namespace yourself. This is also done through an XML namespace tag. However, instead of a URI, you use a special syntax that identifies the CLR namespace and assembly where the type or types you want to use are located. You can see the syntax here displayed on the screen. The assembly identity is made up of 4 items referred to as the 4-part assembly, although it is often shortened to just be the assembly simple name. Note this doesn't include the extension, so don't include .exe or .dll. The assembly portion is only required if the type is not in the current assembly. So if you are creating local types that are defined in the same assembly as the XAML file, then you only need the namespace. You can still include the assembly if you like, but it is optional. You can define a custom namespace either on a specific element or at the root element where it can be shared across multiple child elements. Here you can see a definition for a systems.collection.generic list, where the T is identified as a system.string. There's a couple of cool things here. First, unlike WPF, you can instantiate generic objects using the XAML keyword x:type arguments to supply the specialization type. This comes from the XAML 2009 specification and is supported by the Xamarin parser. Second, notice the string is defined as x:string. This is also part of the XAML 2009 spec, which defines all basic intrinsic types in the XAML X namespace. You can, of course, also create strings by defining a custom namespace against system and Microsoft Core Library. This is exactly what we must do on most of the Microsoft platforms, but with this support, it's not necessary. Keep in mind that the object graph created by XAML is actually the same as your code behind class. In other words, you can navigate through the relationships in code by accessing the content property and casting it to whatever type you want it to be. In fact, you could pick off any object you like this way, but it's a very fragile way to identify objects because you're depending on the structure of the XAML without any guarantee or compile time verification that your assumptions about it are correct. The proper way to find elements created in the XAML is to give them a name. This is done through the XAML keyword x:name. This does two things. It adds a private field to the generated code behind file that will be mapped to this element, so we can use that field to interact with the visual element, setting runtime properties or handling events. Second, it makes the element known to XAML through a name, so you can refer to it from other elements defined in the same XAML file, a feature used in data binding. Since this creates a field, you can't use any arbitrary string. Instead, it must conform to the naming conventions for a variable. It also must be unique, as it will be compiled into your code behind definition. Once you've provided a name for an element, you'll be able to interact with that element in the code behind file just as if you had defined it in your own code. Here you can see we are hooking into the text change event for our phone number. One important thing to remember here is that the field won't be initialized until the initialized component is executed. So any code that interacts with the element should be placed after this call, as you can see in the slide. While not a common practice, you might decide to allow external users of your page to access the visual elements created in XAML. You can easily do this by wrapping the private field in a property. A better approach to this would be to expose the actual data you want them to manipulate. For example, in this case, what I likely want them to be able to control is the text property. In that case, I would want to expose just that string property from here. You should not provide a setter. Replacing the field's value will not change the actual element on the screen. Another way to wire up events is through an attribute in XAML. Attributes can either set properties like we've done or wire up events. The event must be public, as the syntax will simply add an event handler in the generated code behind, just like you might in your own file. Also, the actual handler must be placed into your code behind file, for the same reason, because it's being wired up into the partial class definition. The handler itself can be any visibility, but here it's private. But you could make this public, protected, internal, or any other valid value. One point that needs to be made about event handling is the separation of concerns issue. Wiring up events in XAML is convenient, but it mixes the behavior of the control with the UI definition. Many developers prefer to keep those things distinct and perform all the event handler subscriptions in the code behind to named elements. This makes it easier to see what is hooked up and where the behavior is mapped to. It also makes it harder to accidentally break the code by removing a handler in the XAML without realizing it. This won't be caught by the compiler and will only show itself as an issue when the code doesn't perform that behavior properly. By contrast, if you remove a name off a referenced element, the compiler will complain and it will immediately be obvious that the code behind in the XAML are out of sync. You can use either approach, just pick the one that you prefer.
Here we're going to talk about XAML markup extensions. The idea here is that assigning a literal value in your XAML is a bit limiting. For example, here I'm assigning 3 properties. First one's a literal string, and the text property there is a string, so the types match. These 2 examples are slightly more interesting because type converters run before the value gets assigned. But still, the core of the idea here is we have hard-coded literal values in our XAML. And that makes it really limiting. For example, it's hard to do more interesting things like set the border width to the same value throughout the application, or what if you don't know the border width value until runtime? So in those cases, you need something more sophisticated than a hard-coded literal. And that's what markup extensions are for. They just give you a little bit more flexibility in how you obtain a value that gets used in XAML. So markup extensions are classes. They all implement this interface, which means they supply this method. So this method gets called during XAML loading. It produces a value, and whatever it returns gets assigned to the attribute in your XAML. So notice the difference. We're not hard coding a value at compile time. Instead, we're computing a value at runtime. There's several markup extensions that are predefined by Xamarin Forms. Some of them come from the XAML spec, some come from WPF, and then there's one that's unique to Xamarin Forms. In this section, we're going to talk about those 3, and a few of the other ones are covered in later sections. The first one we're going to do is static extension. The idea here is you have a symbolic constant in your code behind, and you'd like to write XAML that's going to reach into the code behind and access one of those symbolic constants. And it could be a static property, a static field, or any new value. First, notice the name of the class. There is a naming convention here that most markup extensions follow. They use the extension suffix as part of the class name. That's not required, but it is almost universally followed. Then they have properties, and you can think of these as arguments that get passed to the extension to help it do its job. So in this case, the static extension, what you're asking it to do is go to the code behind and look up a member for you. And so you need to tell it what member to look up. That's what that property is for. And of course, it implements the markup extension interface, so it has the provide value method. X:static will let us access that property from XAML. Here's the finished code about how you would do that. First, notice we're assigning to the border width property, right, in XAML. And after the double quotes, we have an open curly brace. That's what tells the XAML parser that we're using a markup extension. It tells the parser there's something special going on. We don't have a literal value in this case. Instead, we have an expression that needs to get evaluated in order to produce the value. Then we have an assignment to member equals, and that's telling the static extension which member in the code behind we want to access. So that expression right there is kind of complex, so let's step back a second and break it down one step at a time. So first, notice that we're using the markup extension in line with the attribute syntax, and that's the most common case. There's a few situations where you use them with element syntax, but those are pretty rare. Next, notice we start with the curly braces, and again, that open curly brace right after the double quote, that's the key thing. That tells the XAML parser we're using a markup extension. After that, we have the name of the class, in this case, static extension. If the class uses that convention where it has extension as the suffix on the class name, as a convenience, as a shorthand, you can leave off the word extension, and the XAML parser will still figure this out. It knows that it's looking for a markup extension because it sees that open curly brace, and it will look behind the scenes for a class named static or a class named static extension. So in this case, it will find the appropriate class. Next, you have to say which member you'd like to access. The first part of that is the assembly and the namespace that contains the class. So in this case, XMLNS there, I'm defining a prefix that includes the assembly and the namespace where the main page class lives. And then I have the actual name of the code behind element, in this case, mainpage.myBorderWidth. There's one final simplification. If the markup extension defines a content property, in this case, the static extension does, content property is member. That lets you simplify this a little bit more. So that member equals, you can actually leave that off and slim it down to that. So now we have the minimal use there of the static extension, markup extension. The next one we're going to look at is x:type. The job of x:type is to take a string and produce a type object. So in this case, we're going to give it the string label. Behind the scenes, it's going to use a type resolver to obtain the type object for the label class and return it. And here's the last one we're going to look at, x:array. This one's interesting because this is one of the only ones that you use with the element syntax instead of the attribute syntax. So notice x:array there is used as an element. So this lets you create a collection directly in your XAML. You do need to tell the array what the type of the element that it's going to store. And in fact, this is one of the main uses of the x:type markup extension. So in this case, we're asking x:type to take that string there, int32, look up the type object for the int32 struct, and return it to us. And that's going to get assigned to the type property of the array markup extension. In real code, this isn't terribly useful because you have hard-coded data in your XAML, but for prototyping, this can be quite useful to get test code into your XAML. Before we end here, let's just look at one special case. Suppose you wanted to produce that as your output. In particular, notice the open curly brace. So open curly brace is a special character in XAML. If you just try to do that, it won't work. You need to escape that open curly brace somehow. And of course, that closed curly brace on the end, that's not significant. It's the open curly brace as the first character in that string that makes this special. So you need to escape that somehow. There's the syntax to do it. Open close curly brace escapes that next open curly brace and will produce the output we see on the screen. Here we're going to talk about using platform-specific values directly from XAML. When you're building your UI, you may find that you need to tune it slightly for the different platforms. Here's a classic example. This is the same Xamarin Forms app running on 3 different platforms. Notice the top there. It looks fine on 2 of them, but on iOS, the app overlaps the status bar. So I'd like to set a padding here where the top value is 20 units on iOS, but 0 on the other 2. If we were doing this from code, it would be easy. We could just look at the operating system at runtime and return the appropriate value. But our goal is to do it from XAML rather than from code. This is a UI-specific value, and arguably it's more appropriate, more convenient to do it from XAML rather than code behind. Xamarin Forms has a nice utility class to make this easy. It's called onPlatform. You give 3 different values, and then at runtime, it does that switch statement for you. It's just a type converter that returns the appropriate value for the runtime platform. So notice onPlatform is a generic, and we do have to specify what type T will be. If we were doing it in code, well, it's easy to do. But our goal is to do this from XAML, not from code. And the XAML specification has a way to specify generic type arguments. The x:type arguments directive is built into the XAML language, and that's the way you set what T should be. Here's a more complete example. So the type here will be color, and then there's 3 values for the different platforms. And of course, we would use this as the value for some property of type color. Right, so in this case, I nest that inside the setting for a background color. Here's a more complex example. So our goal here is to solve the problem we saw in that first example where the top padding needed to be 20 units on iOS. So we're setting the padding property of the page. We're using an onPlatform object, and in this case, padding is a thickness. So we set the type argument to thickness, and then we provide 3 thickness values for the different platforms. Now, the way of doing it there is kind of verbose. Let's slim this down a little bit. So for the moment, put aside the idea of on-platform, and let's just talk for a moment about thickness. That's the verbose way of creating a thickness object where you specify values for the 4 properties. But creating a thickness in XAML is so common, there is a type converter from string. So instead of the yellow line at the top there, we can just put that string 0, 20, 0, 0 as a shorthand. So if we apply that to the code we had a moment ago, right, it slims down to this. Those 3 strings represent the thickness objects for the 3 different platforms, and this is quite a bit nicer looking. And as a final simplification, notice that for Android in Windows Phone, we're using all 0 values, and that turns out to be the default for a thickness object. Therefore, we don't have to put those at all, and we can slim this all the way down to that. So there's an example, sort of a classic use of on-platform to set the top padding to 20 units on iOS, but leave it at 0 on the other platforms. Here we're going to talk about reusing XAML views. So our goal is to create a component and then use it either on a different page or in a completely different application. This is the example that we'll use. It's a login view. And let's just take a couple of minutes to talk about what this thing does. The first thing that's interesting is it's going to take in a string from the client code and use that as the prompt here. Because remember, this view right here is going to be embedded in someone else's code. They're our client. When they instantiate this thing, they're going to give us a string, and we'll take that string and load it into the UI for them. We have a couple of text entry fields. That's pretty straightforward. And then we have a button. When the user clicks on that button, we, inside our component, are going to retrieve the values for the username and password, and then we're going to raise our own event and pass those values back to our client. So we're not going to do the actual validation of the password, we're just going to send it over to our client. Our UI is going to be done in XAML, and our behavior in code behind. Here's our UI. First thing is that prompt we talked about, then a couple of controls for the username, similar thing for a password, a button, notice with a click handler installed, and everything arranged in a grid. There's 2 interesting bits of the code behind. The first is that prompt here. Right, notice we have a name on the label, and then code behind that loads the client's value into our UI here. And there are more clever ways to do this. That's the simplest way I could think of, but you could use something like data binding, for example. The other interesting bit is the login button. We have a click handler installed on that button. When the user clicks the button, we raise our own event, and we pass the username and password along to the client. So now we know what we're trying to package. The next step is actually grouping that stuff together into a reusable view. And the way you do that is with something called a content view. So a content view is a container. So it can hold both our UI and our code behind, and it can group it into a single unit. But itself, it is a view, which means it can be embedded into a larger context, for example, into a page. So here's how you do it. There's our UI. Notice we've just taken the grid that we had before and then used content view as the root node for our XAML. In our code behind, all we do is inherit from the content view class. We're going to have 2 files, the .xaml file and the .xaml.cs file. Xamarin Studio has a nice template that will stub out both of those files for you. So now we have our UI component defined. We'd next like to package it so that our clients can use it easily. There's a couple of ways to do it. Here's the simplest one. We could just include it directly in our app. And that would let us use it across different pages within this same app. A more general option is to create a separate library, for example, a Xamarin Forms class library, and define the component in there. And now the component is separate from the current application and can be reused across any application we need. So this is the more general case, so let's finish talking about this one here. So we'd like to now use this view in our application. Again, we have it packaged in its own library. The first step is everyone that wants to use it needs to reference that library. So it's both the Xamarin Forms application project, the first one there, and the platform-specific project. So everyone needs to reference the library. You need a prefix in your XAML, and this prefix just tells the XAML parser where this login view class lives. So notice it contains the assembly and namespace where this UI component is defined. And then you include one of these views on your page using the prefix. And finally, notice that you can set properties. So there's prompt equals, and we will, inside the component, grab that string and load it into our label. And then there's a subscription to the login view's login event. So when the user clicks the login button inside the view, the onLogin method here inside the page will get raised.
In this demonstration, we're going to have a look at a simple XAML page and try and identify some areas where we have repeated hard-coded values on that page. Let's go and have a look at the standard tippage.xaml file. And so what we're looking for is repeated XAML and hard-coded values. And some good examples are the background color on the grid, which is hard-coded to silver. Also, we can see on each of the labels we're repeating values. So for example, text color, which has been set to navy for each of these labels. Also, our font size is repeatedly hard-coded, and even our font attribute of bold. So these are all classic examples of repeated XAML values and hard-coded values. And these will make your XAML really hard to maintain over time. For example, if you wanted to change the label color, you'd have to identify each of the locations and hope you find them all and then change them manually, which is not ideal. In this demonstration, we saw how XAML pages can often contain repeated or hard-coded values.
The idea of having a symbolic constant is common in code. There are two advantages. First, you can use a descriptive name, for example, high contrast foreground color. Second, it's easier to update because the value is defined in one place. We can do a similar thing in XAML using resources. A resource is any object that can be shared across your UI. You define a resource once and apply it in many places instead of using a hard-coded value. Maintenance is easy too because the value only appears once. In XAML, you can store resources in a shared dictionary and look them up everywhere you need to use them. A resource dictionary is a key-value pair dictionary that is customized for use with UI resources. The library class resource dictionary is the dictionary hard-coded to map string to object. It is similar to a systems collection generic dictionary with key-value pairs. It has a small amount of customization to hold UI-specific values, for example, implicit styles. The add method takes the style, generates the key internally from the fully qualified name of the style's target type. Every page can have a resource dictionary. You use this dictionary to store resources that will be used exclusively on that page. You can create and load a dictionary from either code or XAML. It is primarily used from XAML, however, there are a few cases, which we'll see later, where you need to access it from code. The page's resource property will be null by default, so you need to create a resource dictionary object. Resources are most often created in XAML. You declare them inside a resource dictionary. When adding a dictionary, you need to specify the key and value. Use x:\key to set the key. The object you create becomes the value. Name resources based on use, not value. This will make it easier and more intuitive to change the styles down the road. For example, here you can see we are setting the label to be red, but instead of naming it red color, we should be naming it background color. You use the static resource markup extension to look up a resource in a dictionary. You provide the key and it returns a value. Property settings that use static resource are static. The lookup happens once the target object is created. The target property is not updated if the value in the dictionary changes. Static resource throws a runtime exception if the key is not found. The XAML specs define many types you can use for XAML resources. Resources are often used for things like font size, which have a type double. XAML natively supports many of the C# simple types and provides keywords to make it easy for you to create instances in your XAML. Let's finish with a slightly more complex example. Resource dictionaries map string to objects so they can store anything you need, even on-platform objects. Here we are using on-platform to set the text color to a different value on each platform. So for iOS, the text color will be red, Android blue, and Windows Phone green. You can reuse this on-platform object throughout the page if you want to change the colors in the future. You would be able to just change them all in one place. In this video, we will explore how to use and update dynamic resources. When working with resources in your Xamarin Form XAML, there may be cases when you want to update the resource values after the application has started. There may be times you don't have resource values ready when your UI is being created. For example, you might store user preferences on a web server and load them at application startup. Static resource will not work for this case. If the key is not in the dictionary, a runtime exception will be thrown. You might want to change the resource values while your app is running. For example, you might want to use resource values to make user preferences available to your UI. The user may select a different color scheme for the application. Properties assigned using static resource will not be updated if you update the values in the resource dictionary. So what are you to do when you want the values to change at runtime? Resource values can be updated in code, which is useful when downloading new values or when you want to let the user make changes to the UI. The resource dictionary is available through a resource property of your content page. Your code behind can add, remove, update values as required. These are just standard dictionary operations. So the next question then is, how do we reflect changes in the resource dictionary? And the answer to that is to use the Dynamic Resource Markup extension. The Dynamic Resource Markup extension retrieves a resource when the target object is created, just like static resource, and it also updates the value changes. Dynamic Resource does two things. It loads the resource value initially when the target is created, and then it listens for changes on the dictionary and updates the UI property value as needed. Dynamic Resource has another big advantage over static resource. If you try loading a resource using a key that isn't present in the resource dictionary using Dynamic Resource, it leaves the property unset. It is not an error and no exception is generated. Dynamic Resource is designed to handle the case where the resource value is not available at startup. So far, we've set resources in XAML, and this is the most common practice. However, resources can be set in code using the setDynamicResource method. This allows logic to apply different resources based on runtime knowledge. This method is available in the View base class and is actually defined on the base bindable object class, which means it's available for all of our UI views. It will load the current value of the specified resource, assign it to the specified property, and then watches for change events so it can update the UI. This is the same behavior as using the Dynamic Resource Markup extension in XAML. Here we have a little app which demonstrates the use of Dynamic Resource. As you can see, as the app is running, we are able to do things like update the entire color scheme at runtime. Resources are great to avoid hard-coded duplicate values in your XAML. However, they can be tedious to apply. Each property value needs to be assigned individually, which yields cluttered, verbose XAML. Notice in this example, we're setting the same 5 properties on each of the buttons. We are using resources for the values, so we don't have repeated hard-coded values. However, the property settings are repeated across these 2 buttons. Users are sensitive to startup time, so it is generally considered good practice to minimize the time it takes for your UI to appear. Here we have text color being assigned from a static resource. When this XAML is loaded, there is a lookup that has to occur to locate the value of the resource. Resource lookup is fast, however, it still takes longer than assigning a hard-coded value that requires 0 lookup. The solution to these problems is to create something called a style that assigns several properties all at once. Styles eliminate repetition and increase performance. A style is a way to group related property settings. It's a collection of setters for a particular type of view. A style is implemented as a collection of setters. A setter is a container for a property value pair. You can create setter objects in XAML. Remember, this represents an assignment statement. So you have to say which property will be assigned and the value to load. The setter in this example will set the text color to white. There is one caveat to keep in mind. The property you are setting must be implemented as a bindable property. In practice, most UI properties that you will need to set are bindable, so this isn't a big limitation. Here we have a style that we can use with a button. Notice that we have a setter for each of the 5 properties that were repeated in the 2 buttons from the earlier example. The style must be targeted at a specific type of UI view. The properties in the style must be part of that view type. For example, all of the properties shown above are a part of the button class. We would not be able to use the same style we created for buttons in a label because that class does not include the border color, border radius, or border width properties. Styles are shareable and as such generally defined as resources. You can apply the same style to many different control instances. You load a style by assigning to the style property. The assignment causes each of the setters to be applied to the target. As we saw, styles are typically defined in resource dictionary, so you'll want to use a resource lookup to get the style you want to apply. You can use either a static resource or a dynamic resource to look up the style in the dictionary. The style property is defined in the visual element class. Most controls inherit from visual elements, so the property is available in most controls. Using a style has 2 nice benefits. 1, the resulting XAML is cleaner. There is just one property setting instead of several individual settings. And 2, it encourages consistency. If you assign individual properties to many controls over multiple pages, it's easy to miss one or use inconsistent values. If 2 styles use the same property value, you can factor that value out into a resource and then apply the resource in the 2 setters. This lets the styles share a value which reduces repeated code. In this example, we have resources for background color and foreground color that we use as the setter values. You can use either static resource or dynamic resource for the value of a setter. The 2 options behave as usual for them. Static will not update if the underlying resource changes, while dynamic will. It's tedious to apply a style to every control in your entire application. It would be convenient if we could have a style applied automatically. Styles can be automatically applied to all controls of a target type. Normally, when you add something to a resource dictionary, you must specify both key and value. There is a special case with styles. A style without a key has a special meaning. It becomes an implicit style that is automatically applied to every object of its target type. The matching of implicit styles to controls requires an exact match for the types. That is, an implicit style with a target type of visual element will not be applied to a button since their types do not match exactly. Suppose you're considering whether to use a style written by someone else. It could happen that the style is almost but not quite perfect for your needs. For example, it might have 5 setters, 4 of which use values you want, but 1 of which isn't quite right. You can go ahead and use the style, but then override the inappropriate value. Styles provide the default values. Explicit property values on the control are applied after the style and take precedence. Suppose you have a property setting in a style. You apply the style to the control, but then explicitly set the same property directly on the control. The direct setting overrides the one from the style. The property will take on the value in the direct setting. A style can target a base type of the object to which it is applied. You can write a style that targets a base class. The style can be applied to any of the derived types. For example, here we apply the same style to both a button and a label. Note that this is a different rule than implicit styles. With implicit styles, the types must match exactly. That's not true here since we are using explicit application of the style. Let's finish with a special case that's interesting and shows a slightly more dynamic way to achieve what we've been talking about. It is possible to create a style in code. This lets you use runtime determined values in your setters. This is rare but can be useful for code-generated UI or when you need the full power of a code behind to create, modify, and update the style at runtime. It is common for 2 styles to contain a duplicate setter. You might be trying to create a cohesive look for your UI where your controls use a consistent background color. The background color setting will then likely appear in more than one of your styles. Here's another case where this can happen. You might want all of your buttons to look basically the same. However, buttons that perform important actions like buy, cancel, or submit might be emphasized by using a different border color. You would have two styles both targeted at button that would contain all the same setters except for one border color. If you are not the owner of a style, it might not be possible to modify it to fit your situation. You could apply the style to your controls and then add explicit property settings to override the style values you don't want. However, this is tedious to code and results in repeated XAML. A new style can be inherited from an existing style. The new style inherits all the setters from its base. Use based on to indicate your style's base. You have to use a static resource to identify your base style. The target types of the base and derived styles must be compatible. They can both target the same type. The base style's target type can be a base class of the derived style's target type. A derived style will typically want to modify its base. It can extend its base by adding a new setter that did not appear in the base, and it can customize the base behavior by including a setter for the same property as a setter in its base. The setter in the derived style overrides the one in the base. In this video, we will look at how to share our resources across all of the pages in our application to avoid repeated code. Resources defined on a XAML page are only available on that page. Since most apps have more than one page, page-level resource dictionaries are not really sufficient in helping to avoid repeated code. Resource dictionaries are available in classes all the way throughout Xamarin Forms UI. Visual Element and Application have built-in resource dictionaries. These are initialized to null by default. The Visual Element class defines a resource property. This class is near the root of the UI hierarchy. Controls, pages, and layouts all inherit from Visual Element, so they all have a dictionary. The Application class also defines a resources property. Application does not inherit from Visual Element, so it is defined on its own. Resources can be defined at many different places and many different levels. You decide where to put your resources in the application based on where they're used. Page and application are probably the most common location for resources. So things that are in only one page are generally defined on that page, and resources you want to share across pages typically go into the application. So let's take a look at the lookup rules. Dictionaries are searched starting at the point a resource is applied. Then they go up the visual tree to the page and finally to the app. The visual elements on a page form a tree structure, often called the visual tree. Each element in the tree has its own dictionary that might contain resources. The resource lookup process first searches the dictionary of the element to which the resource is applied. For example, if you set the background color of a button, the button's dictionary is searched first. If no key is found, it will search up the visual tree to the page and then to the application-wide dictionary. The search stops as soon as a matching key is found. To define an application-level resource in XAML, you need a XAML file associated with your app class. Currently, the project templates do not include this file, so you will have to create it manually. The file names app.xaml and app.xamlcs are just used by convention and are not actually required. Resources that you define in your application's dictionary are available in your entire dictionary, and you can use either static resource or dynamic resource to access them. Each resource dictionary is independent, which means that the same key can be used in more than one dictionary. Having the same key in multiple dictionaries on the search path will not cause an error. The resource associated with the first matching key on the path is the one that's going to be used. Let's take a look at some basic guidelines for global styles. Use explicit styles at the application level and then put an implicit style on each page that uses based on. Placing implicit styles at the application level helps sharing, but can obscure which style is being applied on each page. Here is one technique that can make things more clear. Use explicit styles at the application level, define an implicit style on each page, have the implicit style based on the application level style. Do not add any setters to the page level implicit style. Its purpose is simply to convert the explicit application level style to an implicit page level style. This also allows new styles to be defined which are based on the application level. If the application level style were implicit, then it would not be possible to customize it. There is no way to define a style based on an implicit style. This approach makes it clear which implicit styles will be applied on each page. Applications should respect the user's device-wide preferences for appearance and accessibility. Ideally, apps will update their UI when settings change. In this video, we will discuss how to use built-in styles to work with the user's device settings. Operating systems let users choose some device-wide preferences. The most common setting is text size. Users would likely appreciate it if your app's UI incorporated their device-wide preferences, and also updated those settings immediately when they change their preferences so no restart is necessary. Xamarin Forms gives you several predefined styles typically called built-in styles. The built-in styles are generated via code at startup. If the user changes their device-wide preferences, the styles are updated. The style objects are stored in device.styles. Styles is a class nested inside of the device class. This is mostly an implementation detail that you would rarely need to know. The built-in styles target the label class. The main goal is to let your app incorporate the user's choice for text size. The details of the built-in styles are subject to change and may vary by operating system. The device.styles class defines a string that identifies each of the built-in styles. These strings are important to know because you use them in your XAML to identify a built-in style. To apply a built-in style, you use dynamic resource and the value of the style key. Using static resource to attempt to access a built-in style will yield a runtime exception. Dynamic resource is required because these styles are generated via code and can change at runtime if the user changes their preferences. The base resource key is an alternative way to set the based on style and is required when working with a built-in style as your base. Base resource key lets you use a built-in style as a base. It performs a dynamic lookup which keeps the property values synchronized to the user's preferences. It is analogous to dynamic resource. It maintains a link to the underlying style, so when it's changed, the change propagates through to your derived style. You actually can't set based on to a dynamic resource because it's not a bindable property, and style doesn't derive from bindable object. The use of base resource key isn't exclusive to built-in styles. You can use it with your own styles if needed. For example, suppose your base style was dynamically generated and it was not available at startup. Using based on won't work in this case since it only supports static resource. Another example would be if you wanted your base style to change dynamically. You could write code to remove or replace the base style in the dictionary. With base resource key, all your derived styles will automatically update when this happens.
Thank you for joining us for Introduction to Xamarin Forms. In this course, you learn the basics of building cross-platform applications with C# and Xamarin. You created 3 applications with UI, both in code and XAML. You added behavior and used resources and styles to minimize repeated code. To take your skills to the next level, we invite you to join us at Xamarin University, where we offer a wide variety of courses. You can take more advanced topics in cross-platform development, or you could decide to focus on Xamarin Android or Xamarin iOS development. And with that, we bid you farewell and thank you very much.